So, you might look at our created model and think this won't stand when we subject it to an analysis. And you'd be completely right. Let's change that. For restraints, we'll be adding a new combo box similar to the ones we added previously. But, this time, we'll add it to our user form instead of our worksheet. Let's do the usual and change the style property to a drop-down list. And let's also create a new procedure called UserForm initialize. This works exactly the same as a workbook or worksheet initialization function, except this will run when we show our form. We'll use it to do the usual of clearing combo box contents, adding items and selecting the default index automatically. Let's add the pinned and fixed items for both types of restraints. We'll also prepare a space in our worksheet as we did before. Okay, let's add a new procedure called add restraints. It will receive the total x and y lengths. You'll see y in a bit. It will also receive a Boolean flag called isPinned. We'll assume by default that restraints are pinned, otherwise, we'll assume they're fixed. Let's declare the same variables we used for the selection function before. As well as a tolerance variable and an array of booleans called restraint value. This array is taken by the function to determine which axis of displacements and rotations we are restraining. We'll resize our Boolean array to contain 6 elements, and we'll set the first 3 elements to true. This is because, regardless of which type of restraints we're using, we always want to restrain the displacements about all 3 axes. If we have a fixed type of restraint, we'll also restrain the rotations about all 3 axes as well as the displacements. Next, we'll get the selection of points at the base of our model to apply restraints to them. For this, we'll select the points by using a bounding box that starts at slightly below 0 in every axis. We'll set our tolerance to around 1 cm and use that. The bounding box will also go slightly above the floor dimensions as well as slightly above 0 in the z-axis. With this, we should be able to select all base points and cycle them after calling the getSelected function. Let's add a cycle for our selected objects. Add a check to see if the object is a point and call the setRestraint function in the point object and provide it with the restraint values we filled previously. Alright, that should do it. Let's just call our newly created function from the main application procedure and test our code. We'll just add a small check to see if the uppercase text of our cell says pinned. Notice that, if we input any text that differs from pinned, the function will still run but with fixed restraints. We're doing this because we're relying on the combo box from our form to write the text. We could be stricter about this, but there's really no need for that. Great! Let's also test that it works with fixed restraints. all working as intended. Next, let's add some basement walls to finish inserting objects into our model, at least for now. For this, we'll be making the last adjustments to our user form. Though we will still use it to prepare more of our worksheet, we won't be adding any more controls, only making small changes to the code itself. Let's use this opportunity to touch on some more event handling features. We already have some event handling in our code, like the procedure that handles the user form creation and the procedure that handles the button press in our form. Every macro we've created so far has, in essence, been exactly this. You can think of event handlers as functions or procedures that are automatically called when a certain state or property changes. Let's add a checkbox and a text box to our form. We'll make our checkbox be the one that verifies if we want to add basement stories or not. Then, we'll add a new function in our code with the name of our checkbox, then an underscore and click. This function will be called when we click the checkbox. VBA automatically assumes it's the event handler function because of its name. And this function will be quite simple, just one line actually. All we need to do is invert the enabled property of our new text box. The enabled property allows us to decide whether the user can interact with any particular control of our graphical interface. Since we're starting with an unchecked checkbox, let's manually alter the enabled property of our basement stories text box to false. Finally, let's also add a default value to our basement stories text box, and let's add some code to our button click function that prepares the worksheet and writes the number of basement stories if the checkbox is checked. Now, if we launch the form, we can see that the text box is not enabled, even though it has a value in it. If we click on Prepare Sheet, we'll see that the value was not written to the worksheet, and we have a 0 instead. Let's try enabling our text box by clicking the checkbox. As you can see, clicking on the checkbox activates or deactivates the related text box. Okay. Let's code our basement walls function. Our function will receive the number of basement stories, the story heights, and the x and y lengths. We'll declare the usual cycle variables and some variables for dimensions. We'll also declare a variable for the model tolerance and set it to 1 centimeter. Then, we'll declare the coordinate arrays for each dimension and resize them to make them dynamic arrays. And we'll set the starting z-coordinate. Let's add our 2 cycles and we can set the same z-coordinate array for each floor. Then, we'll use our wall index cycle variable as an identifier for the specific wall we're adding to the model. There's no immediate way to identify which wall we're putting into the model, as opposed to stories which always go up, so we'll make our own logic that goes like this. Minimum y, maximum y, minimum x, and then maximum x. We'll also set the coordinates for each one in a way that makes the normal vector of the created wall point inwards towards the center of the building. That way, the forces applied to our wall by the surrounding ground will be counted as positive. Let's also use these specific coordinates of each case to perform a selection operation. We'll do this to divide our basement walls via the cookie cutter method immediately after we create them. This way we don't have to call a different function and make our code even longer. Okay, all that's left is to call the add by coordinates function regardless of whichever wall we're adding. Then, we'll call the divide function to divide our walls by cookie cutter method as we did previously for the floor slabs. Let's test out our code. Everything seems to work fine. We can set the view type to extrude so that we get a better understanding of the model. Now, despite everything being okay with the walls, you may notice we still have some horizontal frame elements in our perimeter that should have been removed. Let's fix that very quickly. We'll create a new procedure called delete selected objects that will receive an object type. This will be quite similar to other functions we've made in the past, so we'll just speed it up a bit, but, essentially, this function will depend on a prior selection already existing and deleting all items of the given type in said selection. Then, it will clear the selection just as a preventative measure. Alright, let's now go back to our basement walls function. After we call the divide function, our selection will be cleared. Since reusing the selection that was just cleared would be useful, let's use the previous selection function that rescues the cleared selection. Then, we'll call our new function and tell it to clear the frames it encounters by giving it the item type 2. Okay, let's test our code once again and make sure everything works the way we want it to. Now switching to our extruded view type, we can see that those pesky frames were erased. This concludes this part of the course focused on adding objects to our model. Just as a recap, we now have fully functional code that can launch a custom user form that prepares our worksheet, creates a frame grid, adds floor slabs and basement walls. All this while supporting custom story heights as well as custom bay lengths and different restraint types. Next, we'll be focusing on adding all that we need to run a successful analysis of our custom templates. We'll be adding loads, load cases, and patterns and a custom response spectrum function.